Very good. So, condensation reactions. These are next. Condensation reactions, if you do biology, these should be a walk in the park. If you don't do biology, that's okay. These are still a walk in the park for everyone. So, condensation reactions, essentially, think about condensation on your window. Think about when you have a really hot shower and you've got like water dripping down the window. It's like, you think it's like steam. It's condensation because it's just different temperatures around things. And essentially, condensation is just water. And that's what a condensation reaction involves. The removal of water. As simple as that. So, when an amine group, NH3, is substituted for the OH group, the reaction conditions are the following. And as you can see there, you have taken this off, and you have added this to here. That's what's going on. But if you notice, you have OH and you have a H left. Well, it's two hydrogens and an oxygen. What's that make? It makes H2O. It makes water. So water has been removed. Water is the byproduct. When water is a byproduct, the reaction is a condensation reaction, no matter what. If water is a byproduct, it is a condensation reaction in chemistry. Really important. So in this case here, this is a condensation reaction because you've had this change from a sort of a condensation reaction to from a alcohol to an amine, but you've also had water removed, so it's a condensation reaction. There are some other examples of this, especially when you form an ester. So when you form an ester, you have water come off. That is another really common example of condensation reaction. Now, as you can see here, this is the esterification. This is also a form of condensation reaction. So esterification is sort of like a subcategory in that condensation reaction here. So the esterification reaction occurs when a carboxylic acid reacts with a primary alcohol and yields an ester. So really, really important. There's two things here. It requires heat. So when you're running your arrow, it requires heat. It also requires concentrated H2SO4 or liquid H2SO4. So if you write H2SO4 aqueous, you are wrong. Wrong. It's just wrong. If you write H2SO4 aqueous concentrated or concentrated H2SO4 aqueous, you are correct. If you write H2SO4 liquid, you are correct. They are the only two acceptable things for the catalyst. Why? Because in this reaction, if we think about it in terms of, let's think about this in terms of equilibriums. If I have just aqueous H2SO4, I've got heaps of water. What's this reaction going to want to do? It's going to want to go backwards. Why would it want to go forwards if I've already got heaps of water there? So this is like taking into account our equilibrium now, and we're thinking about equilibrium reactions. This thing doesn't want to go forward if there's already water there. So you mustn't have water there. So concentrated H2SO4, even though it's got a little bit of water, it's not a lot, but H2SO4 liquid just has no water. So it's the best option. So as you can see here, H2SO4 is definitely the best option. You add your alcohol, your carboxylic acid to your alcohol, and you get this formed here. Really important. That is where you split it if you're thinking about this molecule. This is the carboxylic acid side, so you've lost this. And then this is the other side is the alcohol, and you've lost that. Now, I don't know if I go through naming, I don't. In this question here, it's a bit easy because the naming is going to be the same because this is eth and this is eth. But let's say for the sake of it, I added in a carbon here with 3 hydrogens. So I get rid of that and then I add in 3. So this now becomes prop. How do I name this molecule? Well, the naming of this molecule is really important. This is now the alcohol side because I've split it here. So this is going to be prop. That's a terrible P, but it's a P. Prop. Now, this is all single bonds, so it's ane. But we don't put ane, we just put il. If there was a double bond or a triple bond, you would put that in there. If it's ane, you don't. Now, you don't need, for VCE level, you're not going to need to worry about it. It's always going to be ane. They're not going to throw you a curveball here. It's just always going to be ane. So, propyl. Then here, this is eth. Now, you do need to put the ane here. So if there is a triple or a double bond, you do need to put it in, and you do need to put ane, ethanoate. So the O8 goes on the carboxylic acid side. So the carboxylic acid here was eth, or ethanoic acid. And then your il, which goes first, is your alcohol. So we're assuming here this was propanol, because I've made it bigger to change it up. But propanol, so propyl ethanoate. Really important. Been talking too long. Sorry, everyone. So propyl ethanoate, really important. And it has water coming out, so this is your reaction here.